Know about asymptotes. I say horizontal asymptotes. How do we find horizontal asymptotes? Let's get some hands on this. What would you do? How would you find horizontal asymptotes? Horizontal asymptotes. You need to use your notes from the other day, that's fine. How do we find horizontal asymptotes? Just Aaron? Oh, so sad. Only 1 out of 11. Horizontal asymptotes. I want you to think end behavior here. Aaron, how do we find horizontal asymptotes? Or just give me a quick summary. If I said go find a horizontal asymptote, what would you do? End behavior. Sure.
In other words, if limit of f of x equals L as x approaches infinity, or if limit of f of x equals L as x approaches negative infinity, then the line y of L, or y equals L, is a horizontal asymptote of y equals x.
Okay. Set a little shorter. Find the limit as x approaches infinity. If somebody can turn that off, that would be great. Find the limit as x approaches negative infinity. Horizontal asymptotes, we're talking about end behavior. What happens on the ends. So, let's get a quick show of hands on this. I want parent functions that have horizontal asymptotes. Parent functions that have horizontal asymptotes. Don't just tell me what the parent function is, I want to know the horizontal asymptote. Lewis, give me one.
1 over x squared plus 1.
1 over x squared plus 1, that does that hill shape, right? 1 over x squared plus 1 is the hill. Where are the horizontal asymptotes?
0.
Be more specific. I heard 0. Be more specific.
Of f of x approaches infinity. Also it's approaching negative.
Well, you said 0. The horizontal asymptote is a line, so you're gonna express it as a line.
Y equals 0.
Y, right, 1 over x squared plus 1 has a horizontal asymptote of y equals 0. Nice. Other ones, you're frozen for a little bit. Carmen.
Oh, y over x squared horizontal asymptote at...
Wait, y over x squared?
I mean, 1 over x.
1 over x squared. What does that graph look like?
It goes...
Right, it's like that volcano shape. Okay, it has a horizontal asymptote at...
Y.
Well done. Polygon.
Arctan.
Arctan, now you're showing off. What does arctan look like?
Kind of like the value.
I'm not really sure what you do with your arm there, but it does this thing, right? How many horizontal asymptotes?
2.
2. Y equals pi over 2 and y equals negative pi over 2. That's the special one I want you to have locked in your head, David, because it has 2 different horizontal asymptotes. Okay? Limit as x approaches infinity, limit as x approaches negative infinity. This is what we do. Okay, vertical asymptotes. Vertical asymptotes. How do we begin looking for vertical asymptotes? Myra. Or just give me your definition of a vertical asymptote.
So the limit of f of x as x approaches k equals infinity, or the limit f of x as x approaches k equals infinity, then the line x equals k is a vertical asymptote.
Your definition sounds so much like my definition. That is awesome. A vertical asymptote. I know you guys know what vertical asymptotes are. Vertical asymptotes look something like this, right? And we're going to say x equals k. What makes a vertical asymptote is you've got behavior that looks something like this. Is it going to do all 4 things?
No.
No, it can't possibly do all 4 things. But the graph of 1 over x squared does this. The graph of 1 over x kind of does this behavior. Okay, when I'm looking for vertical asymptotes, normally what I do is I set the denominator equal to 0. That doesn't get me my vertical asymptotes though. This gives me what I call my candidates. This is where I might have a vertical asymptote, and then what I'm going to do is I'm going to say, all right, take the limit as x approaches c. I'm going to say either from the left or the right of some function. And what would I expect to get if I'm going to say I have a vertical asymptote? What was that, Stephen?
Wait. There's not even.
If I get a particular thing as my answer, I'm going to say I have a vertical asymptote.
Oh, it's not good because I'm down to gate.
Right. If I see positive or negative infinity as my limit answer, then I'm going to say, oh, vertical asymptote. But sometimes what you're going to see is you're going to see something like, oh, I don't know, some number, let me call it L, some finite number like 5, 12, negative 17. Is that one of the infinities?
No.
If it's not one of the infinities, then that's not a vertical asymptote. What this means is that you have a hole, and the location of the hole is at C, comma L. Where, whatever your candidate was, wherever you have a problem area, that's the x-coordinate. The limit that you get is the y value for the hole. I will tell you, like, whether I've taught pre-calc, calc AB, or calc BC, like this just tends to be a really tough section for a lot of students. There's so many things going on. There's so many things to check. Okay, so I want to go in a slightly different direction than what I have in my lesson plan. So for anybody who's like watching at another campus, you might be like, wait, that's not what you said you were going to do. Let's take a look at 5x divided by x minus 2. I want you guys to first graph it on your calculator. I'm going to take attendance and get some water. Yep. I had faith in you, Lewis. The other option is you were going to blame it on me, and that wasn't going to happen. No. All right, now that you've got this graphed on your calculator, tell me about the asymptotes that you're seeing there.
Vertical asymptote. Is there more?
All right, according to Eileen, her graph looks something like that. Everybody okay with the graph? Okay, just based on looking at the graph, do we believe there's a horizontal asymptote?
Yeah.
Yes.
Just by looking at the graph, you see there's a horizontal asymptote. And so your horizontal asymptote is going to be at y equals something. But in order for me to figure out what's the something, if you've got your calculator in front of you, what could you do?
You can plug in values that approach negative infinity and positive infinity.
Right? You can test values on the graph and say, what happens as I approach positive infinity? What happens as I approach negative infinity? That would work. Okay, give it a shot. What are we going to get? Right? If you're actually like testing values with your calculator, you should see that you're getting closer to 5. Do I have evidence from the graph that I have a vertical asymptote?
Yes.
Okay, and that vertical asymptote is where?
X equals 2.
Wait, where?
X equals 2?
At x equals 2?
Mm-hmm.
Okay, yeah, I do that a little bit badly. My apologies. Okay, so it looks like I've got a horizontal asymptote at y equals 5. It looks like I've got a vertical asymptote at x equals 2. Just by a quick show of hands, how many of you all, based on your pre-calculus knowledge, had a pretty good guess, without the graph, that you were going to have a vertical asymptote at x equals 2? Okay, seems like a lot of folks. And Carmen, why were you suspecting there was going to be a vertical asymptote at x equals 2?
Because of the minus 2 in the denominator.
Okay, because of this x minus 2 in the denominator, like I'd say x equals 2 is a candidate for a vertical asymptote because it could also be a hole. Anybody have any just like good, your gut said there was going to be a horizontal asymptote at y equals 5? Not as many folks there. There was something that you learned last year in pre-calc and you would have been exposed to the year before in Algebra 2 that would give you an indication that maybe there's a horizontal asymptote at y equals 5. But I'm not going to tell you right now. Here's what I want you guys to do. Within your groups, half of you need to graph function number 2, the other half need to graph function number 3. Based on your graph, where do you see a horizontal asymptote if you see any at all? Where do you see a vertical asymptote if you see any at all? And then I want you to try to summarize any connections that you're making. Half of you graph the first one, half of you graph the next one.
Yeah, the first one. The first one's a red track. See, it's the same thing. It's the coefficients and the numerator.
That never made sense.
Did I agree? Back. Get it back. No, is there a note on?
I hate wait, this is gonna be white equals
Huh. Please label your work more clearly. This was so hard to follow because I can't follow your work in section 4. It stops reading. You have until Wednesday to fix this. Okay. Yeah, on Friday, I needed all of the assignment.
He's on the
Sorry if that wasn't clear, but let's just tear this off.
You know this is yours.
Excellent. And we are filming, right? Okay, so now this brings everybody with the exception of you get to
I don't
Wednesday.
know, have y'all graphed it yet? I don't know, have you graphed it yet? Yeah, the second one.
All right, friends
Is
up
it just
front.
that L?
Anybody?
Yeah, that is what it is.
Did you see the grade sheet?
Yeah, it's just
Cool.
Is it? Wait,
Giselle, you turned in all three.
that's the graph from that?
David, you did not turn
But I'm
in all
confused,
three,
it's the
is that
same
right?
graph.
You're missing one. Which one?
No, these two are the same graph. Look how mine came out.
Problem set 3 is the one you would have turned in on Friday.
It was assignment.
Yeah.
I think it's the paper.
Like, I mean, right now,
It should look the same.
Alex, which one are
they used to have a graph. See that? Mine's a red one.
Okay, what you get for the
So you're saying I gave it back to you?
I think it was
Oh,
the
no, no, no.
paper.
This.
The reason you don't have a grade is because your paper gets stapled down. Okay. That'll take care of you. Giselle, you've got everything done?
One was
Okay,
have
my
the
friend
same
over
graph on horizontal. Wait, no, they have the same horizontal.
Wait, which yours?
Similar.
They're vertical asymptotes. They're vertical asymptotes.
Because like mine, like.
Yeah, they're
No,
all
no,
vertical
this
asymptotes.
one, like.
Yeah,
Because they're all shifted.
They don't work like that.
Ours does.
Oh, yeah, they do.
All right, friends.
Or we should.
This guy over here, horizontal asymptote, where is it?
Oh,
Y 5.
Horizontal asymptote at y equals 5. Vertical asymptote.
X equals -2.
X equals -2. I do want you to start thinking and like kind of making the connections, be like, oh wait, I think I noticed something that's happening here. How about function number 3, horizontal asymptote, where is it? What'd you say? Y equals 5? No, not y equals 5. Y equals 2.5. Okay.
Oh,
I did it.
I did it.
Or maybe like 5/2.
I instantly
Yeah.
did it.
And anybody find a vertical asymptote?
Yes, it's negative.
There are some things I wanted like firing off in your brain here. There's a vertical asymptote, -1/2.
I got it.
Okay.
I got it.
What is it?
I refuse to tell you all the things. Absolutely refuse to tell you all the things. We're going to do exploration round 2. Exploration round 2. One of you, decide who it's going to be, is going to graph function number 1. You're going to analyze this function, horizontal asymptote, vertical asymptotes. There might even be a hole. One of you function number 2. One of you function number 3. For my 2 groups of 4, let's have 2 of you do function number 3. Okay, we're going to talk in 5 minutes. Yes, ma'am.
Sorry, two. The first one.
So problem set 3 is what I would have collected on Friday.
The highest degree, you take them and divide the coefficients. So like this one.
Did it have,
would be 10
okay,
over
and so I
5.
think, okay, did you get the paper back from me today? You didn't. That's interesting. I wonder if it got stapled to somebody else's. Because what I picked up was sections 1, 2, and 3. And it looks like you still have section 1 and 2. And that maybe what you turned into me was section 3. Right, but what I was looking for
I think
was all of it, was all three parts. You got me? We're gonna get this all figured out.
Two asymptotes.
Where are the folks that have graphed function number 1? Lewis graphed function number 1. How about my groups up front? Aaron graphed function number 1. Friends up front over here. Who's got function number 1? Okay, can I borrow your calculator for a second? So according to Giselle's calculator, the graph looks something like that. Is there evidence that we have some asymptote behavior? Would most of you guys look at that graph and say, yeah, I think that there's going to be some asymptotes? Right, and maybe you're like, oh, there's an asymptote over here, and there's an asymptote over here. But my question to you all is, where exactly are these asymptotes? This is really important. Where exactly are they? What are we discovering for the folks that did function number 1? Where's the horizontal asymptote? Lewis, where's the horizontal asymptote?
And y equals 2.
Your horizontal asymptote, you have a horizontal asymptote at y equals 2. Vertical asymptote. Where does the vertical asymptote, where does that live? Okay, I'm worried that I'm only seeing Lewis right now. Oh, Aaron, you're the one that graphed function number 1,
We
right?
all kind of work on it.
Okay, so part of it, I need each one of you to own a different function so that we can
I own it.
You owned it. So where is the vertical asymptote?
Initially it looked like it was at x equals 2.
Okay, initially it looked like it was at x equals 2, and then did you do some exploring on the calculator?
I kind of did. So give me a second.
Okie dokie. Yeah.
The candidates were vertical where x equals 0 and x plus or minus square root of 5.
Whoa, okay, hold on. So for candidates, we've got 5x squared minus 10x equals 0. And I heard you say, what again?
X equals plus or minus square root of 5.
X equals plus or minus the square root of 5. How did you get that?
Take out the x, right? And then, wait. No, I did it incorrect. Never mind.
Okay, like if I'm going to factor, maybe I'm going to factor out this 5x to get 5x times x minus 2 equals 0. And we get x equals 0 and x equals 2 as the candidates. 2 candidates. I can see from the graph how many vertical asymptotes. There's 1. The one vertical asymptote that you have is at x equals 2, and I can see from the graph that something's happening there. I'll tell you, there is something happening at x equals 0. What's happening at 0? There is a hole. you will never be able to look at the graph and say, aha, there is a hole. But there are other clues on your calculator that you have a hole. For example,
Table.
if you go to the table, in the table you're going to see that your graph is actually not defined at x equals 0. It says like 0, comma error. If you tried the trace feature and you tried like plugging in 0, you're going to get like undefined of some sort. You have a hole at x equals 0. All right, for the folks that did function 2 and function number 3, finish it up. I need you guys to be able to share with me in about 1 minute what's going on.
This one for the whole sometimes if the degrees are different, how do we know? And it wouldn't
What?
be the same word.
I think you take the highest degree. The coefficient in front of the highest degree.
I know, so does that mean it's why that
Big.
is?
Because the highest degree is at the bottom, and so the coefficient in front of that is high.
So it's one negative 5? So it's only 10.
Okay. Don't me, I don't know. This is what I think.
This is the way the graph is. It's not a normal. I don't think it's showing me any forms of 5. You got a vertical asymptote pattern, and then it's only 4 and 5.
No, there's a horizontal asymptote.
Okay?
On 3?
It's the one that
Yeah, look at it.
that's what it is. It goes like this.
Steven, you doing okay?
Yeah.
So there's no
I think
horizontal.
it's still correct that you still do.
Oh, then
Can you show me how you get this plus or minus
Right.
45?
Oh no, it's because I forgot to take out this
cubic
extra
function.
and put it here.
Mm.
I didn't block here.
I got you.
How at least it's
Because-
the grading is.
Yeah.
All right, so over here, who's on function number 2?
I think that's what we're going to
Can I bring your calculator for a second? All right, according to Myra, function number 2 looks something like this. For anybody else who graphed function number 2, do you guys agree?
Yes.
All right, here you go. Is there evidence that we have horizontal and vertical asymptotes? Sure. Where's the horizontal asymptote? If you do like the explore feature on, if you're like exploring on your calculator, if you check the table of values, if you graph, where's that horizontal asymptote? 1 over 5? Wait, are we doing 10x over 5x squared minus 10x? Where's that horizontal asymptote for function number 2?
You don't even have to do that. Look, they're both.
If you can use your table, you can use the table feature and try like bigger and bigger and bigger values for x. You can trace if you want to.
He's just asking about horizontal asymptote.
Where are those horizontal asymptotes?
You looking for the second one?
Should be
No, one.
-1.
not -1. You might want to check and make sure that you actually type this correctly into the calculator. 10x divided by 5x squared minus 10x.
Zero?
One more time?
Zero?
Oh, see, you're doing it again, so I can't hear you. Because the horizontal asymptote is a line.
Why?
The horizontal asymptote should be at y equals 0.
Are you confused how those two?
Vertical asymptote, there's 1. Where's the 1?
She didn't know that. I was like,
Where's the 1 vertical asymptote? Carmen, where's the 1 vertical asymptote?
X equals 2.
Your 1 vertical asymptote should be at x equals 2. But the problem though is if you do your like, where are my candidates, and you set the denominator equal to 0, you might suspect that there's going to be a vertical asymptote at x equals 0 and at x equals 2. What's happening on your calculator, if you try it again, you're going to get a hole at x equals 0. Okay, and for the folks that graphed function number 3, does somebody still have it on their calculator?
he does.
You do? Okay, come on. Thank you very much. Okay. On the calculator, we've got something that looks
That's why I'm
like this.
Because it doesn't actually get to zero.
If that's your graph, here you go, Palimon.
That's the closest it is to zero. It's not like 0.2.
As x is approaching infinity, is the y value approaching a particular number? As x approaches infinity, those y values are just increasing. As x approaches negative infinity, those y values are just decreasing. So there is no horizontal asymptote.
Why is it on zero?
I do think though we have some evidence of vertical asymptotes. Yeah, where?
X equals 2.
Okay, we have a vertical asymptote at x equals 2 as well.
Yeah, there's a hole. That's what it is.
Now maybe it's because it's Monday morning, or maybe it's just because asymptotes are rough, like all around for all the friends. I was hoping that by this point, some of like the things that you learned in pre-calculus around asymptotes would be kicking in. And that doesn't seem to be the case. There were things that you, Stephen,
Basically, if the degree is higher on the numerator, you can divide the numerator and like the number in the denominator, which has I guess a second higher degree.
so when your function was like a polynomial over a polynomial, we call those rational functions a polynomial divided by a polynomial. There were things that you looked for with the degrees. And as soon as you said degree, Carmen was like, oh, yes. And it like worked its way through the room. And people are smiling now. They're like,
It's even wrong.
yes, that's the thing I was supposed to be remembering. How many of you guys are remembering something about degrees? Okay. Giselle, what do you remember about the degrees? Which was what? I wasn't really listening to.
That if the degree is greater on the numerator, then you can.
When the degree is bigger in the numerator, like for function number 3, where's your horizontal asymptote?
There's none.
Trick question. There is no horizontal asymptote. When the degree is bigger in the numerator, there is no horizontal asymptote. What are the other things that you were supposed to remember, David?
When the degrees are the same.
When the degrees are the same, what do?
You divide.
You divide. It's the leading coefficients that you divide. Where is there an example of degrees are the same?
The first question.
The first one. So where's the horizontal asymptote going to be?
1 is 2.
10 divided by 5, which is at y equals 2. There's one case left.
Where the numerator is smaller than the denominator. The degree.
Okay, which is case number 2. If the denominator has the bigger degree, then what happens to the horizontal asymptote?
Equals 0.
Y equals 0. How do we get vertical asymptotes? Vertical asymptotes, we focus on the denominator. Okay, so we're not going to finish up the rest of the explorations, but let's move on a little bit here. All right. So based on what you remember or just had shoved down your throat, either way, let's look at page 32. There's a problem at the top here. Without using your calculator and without talking to anybody for the next, like, let's call it, minute and a half, I want you to tell me all the horizontal asymptotes and vertical asymptotes or holes that you know.
That's good.
And you know what? We're going to change this problem just a little bit. Get rid of that pesky +1. I didn't want that to be there. Sorry. So just 3x squared over 2x squared minus 6x. When you think you've got it, if you want to check it on your calculator, feel free. You know, most of the time I see you and I'm choosing to ignore you for a little bit.
I have a question.
Yes.
A clarification question.
Yes.
Would you want me to put this in both? Or do you want me to just put it down here?
It has to be in the right one.
Okay, so that makes sense. Okay.
has to be in the right one.
Makes no sense.
When you think you've got it, feel free to check in on the calculator.
It's like these two that we did. Yeah, you got it. You don't need to do that.
All right. All right. Somebody tell me something you are confident about. You look at this function now and you know something. David, what do you know?
That there's a horizontal asymptote at y equals 2.
Horizontal asymptote at y equals 3 over 2. I completely agree with you. How did you make that decision?
I saw the degrees are the same, so I just divided it in coefficient.
We've got a polynomial over a polynomial. We're going to look at the leading coefficient, right? The degrees are the same, and we just take the ratio. Good. Anything else? Anybody know something for sure? Celeste, what do you know for sure?
There's a vertical asymptote at x equals.
You have a vertical asymptote at x equals 3. Now, did you know that before you looked at the calculator?
C.
All right. Anything else?
Removal discontinuity
There's a removable disconnect. Oh my God. Disconnect. You've got a hole at x equals 0. Now, with the hole, what I want to see though are coordinates, because it's like it is a point, it is a place. So, Lewis, I'm going to get really picky when it comes to horizontal and vertical asymptotes. I want lines, but when I get to removable discontinuities, I want like coordinates of a point. Quick show of hands. How many guys are like 100% okay with the horizontal asymptote? Okay. Vertical asymptote at x equals 3? The whole at x equals 0. Everybody's 100% okay with that?
Yep.
Without going to the calculator. Somebody tell me, how do you know it's a whole at x equals 0? What do you know? What is it that you look for? All these people are just like, oh yeah, I know it's a whole. Of course it's a whole. Tell me why it's a whole. Palimon, why is it a whole?
Since the degree is the same, so it's gonna, and there's only gonna be one asymptote, one vertical asymptote. It has to be a whole.
So what I heard you just say is the degrees are the same. There can be only one vertical asymptote, so this has to be a whole. Is that what you just said? I'm not trying to give you a hard time. I just want to make sure. That's what you just said. Could not disagree more. Could not disagree more. You can have lots and lots and lots of vertical asymptotes. There's something very specific that happens at x equals 0 that it is not a vertical asymptote. There's something very specific about the function. Andrew, one more time?
Equals 0 over 0.
Okay. You're getting 0 over, if you were to try evaluating this function at 0, you're going to get 0 over 0. That's part of it. That's part of it. Here's the thing. The way I would make a decision about these two has to involve examining your candidates. It's going to involve a limit conversation. So if 2x squared minus 6x is equal to 0, I know we can solve this pretty quickly and get that x equals 0 or x equals 3. I'm not worried about anybody with that. But here's the thing. Without a calculator, the way that you're going to decide vertical asymptote or whole, you're going to have to go over here and say, what's the limit as x approaches 0 of 3x squared over 2x squared minus 6x? And you're going to have to examine what's the limit as x approaches 3 of 3x squared over 2x squared minus 6x. You need to check both. What happens here, if I take this limit, I'm going to get 0 over 0, indeterminate form. You know that can't be the final answer. So what do? I get 0 over 0. I need some algebra trickery. And that algebra trickery looks like what? What could you do? Lewis, what could you do?
the would be 2x minus 3. Like in the denominator.
In the denominator, the thing that you're doing, it sounds like you're doing the F word. The appropriate F word. Factoring, yes. I don't know what F word you guys were just thinking about. 2x squared minus 6x. I can factor. I think I know which one Aaron was thinking about. Okay, factor out the 2x, you get x minus 3. You've got 3x squared in the numerator. Now what happens? Stephen, what happens?
You basically will cross out the x in the denominator and keep one x.
You can cross out the x. Even better would be to like cancel. Right, I can cancel that x in the numerator, that x in the denominator. Now take the limit as x approaches 0. What do you get? Let x get close to 0. The numerator gets close to 0. The denominator? X gets close to 0. 0 minus 3, negative 3, times 2, negative 6. You're getting 0 over negative 6, which is 0. Is that one of the infinities?
No.
No. Because it's not one of the infinities, this is not vertical asymptote behavior. This is a hole. Specifically, the hole is at x equals 0. It's a little bit awkward because it's like 0 here and 0 here. The x coordinate of the hole is 0. The y coordinate of the hole is that 0. If I go here and I test my other candidate, take the limit as x approaches 3, well, what happens in the numerator? What happens in the numerator? X gets close to 3. The numerator gets close to
27.
x is getting close to 3. Numerator?
27.
27. Denominator?
0.
2 times 3 squared, 18 minus 18 is 0. And here's where we want to be careful. I'm not actually equal to 27. I'm not actually equal to 0. Numerator gets close to 27. Denominator gets close to 0. Whole fraction gets close to one of the infinities, depending on what side. Right? Is this 0 from the left or 0 from the right? So we're going to say that this is going to approach positive or negative infinity. Therefore, we have a vertical asymptote at x equals. All right. Well, you're welcome. I don't know what I did. Oh, great. Now, none of the North Central kids. That's how we roll here at Southwest. All right, take a minute, please, and I want you to summarize the results on the bottom of page 32. What are all the things you are taking away from this morning? And maybe what you're taking away is a headache.
The one for the work for 3? No, I'm missing one. Except for the section 3.
Round 3 at the summer assignment is very inconvenient.
Oh yeah, the back. Actually, the back. I think it has to do the very back too. I think it's even more.
You've got till Wednesday to get this done the right way. All right, and before anybody gets confused, no, these are not hearts. I don't have a heart. I wouldn't use the heart as a bullet point. What is this really? Thank you very much. All right, David, how are we going to determine a vertical asymptote?
Vertical asymptote. We have to look at the candidate,
You're going to look at the candidates. Where do those candidates come from?
the denominator.
Okay, so I'm going to say set the denominator equal to 0 to find the candidates. Now, are you guaranteed a vertical asymptote of the candidate?
No.
No! Otherwise, we wouldn't call it a candidate if you were guaranteed. So if, let's say, I take that limit as x approaches c of f of x and I get one of the infinities, what's your conclusion? Then you have a vertical asymptote at x equals c. But if I take the limit as x approaches c of this function and I get some number, what's your conclusion? There's a hole, and that hole is at c comma L. All right, horizontal asymptotes, where do those come from? Andrew, where do we find horizontal asymptotes?
Looking at the degree of the denominator and numerator.
Okay, but like, what is it that you're doing? If you're gonna find a horizontal asymptote, I want you to think about end behavior. I'm not sprinkling pixie dust here. I'm thinking about end behavior. Like, what's happening as we go to negative infinity? What's happening as we go to positive infinity? So for horizontal asymptotes, you're going to say, what's the limit as x approaches infinity of f of x? And what's the limit as x approaches negative infinity of f of x? You got to check them both. All right, if I have a rational function, and I think, Andrew, this is what you were thinking, where it's like polynomial over polynomial. Okay? If m is bigger than n, if this guy is greater, what do we know about the horizontal asymptote?
Oh,
There is no horizontal asymptote. Okay, if m is less than n, this is the small guy, that's the big guy.
0.
Oh, 0.
Y equals
God, Lewis, that's like strike 3. But you've got broken glasses, so you can't see. All right, if m is equal to n, if the degrees are the same.
A over B.
Okay, but I want to be careful, it's not a over b.
M over N.
It's not m over m, no.
A and
A over M.
initial.
A and initial is a sub 0 and b sub 0. It's
Yeah.
these guys here are what we call the leading coefficients. Okay. Everybody okay? Okay, in terms of homework, what I want you to get accomplished is assignment number 5. It's in the problem set package. Don't pack up yet, I still have like 3 minutes to like make it miserable. Okay? But I forgot to mention the homework at the beginning. So it's assignment number 5. All those problems are due on Wednesday. Wednesday. What I want to do with you guys to close you out is push your thinking a little bit more in the world of asymptotes. We've got 2 minutes. We're only going to go as far as we can go. All right, we're going to look at the function 5 over e to the x minus 1. This question showed up on the AP exam a couple of years ago, and it was so bad they threw the question out. They didn't include the question in the data. That has happened like once in about 20 years. This question was so bad. So let's look at this. I want to find horizontal asymptotes. The trick that you know about the degrees is a trick that you use when you have like polynomial over polynomial. Is that what we have here?
No.
No. So how do we find horizontal asymptotes? How do we properly find horizontal asymptotes? End behavior. So I need to find the limit as x approaches infinity of 5 divided by e to the x minus 1. Let's see if we can do this in our heads. It's infinity, I can't plug in. That would be bad. I see 1, I see 2, I see 3. I see some folks that are like maybe having the right conversations in their head. X is approaching infinity, where do I go first? If x is approaching infinity, the thing that I care about? E to the x. What's happening to e to the x?
As x approaches infinity.
As x approaches infinity, e to the x is approaching.
Infinity.
Subtract 1 from that.
Still infinity.
Still infinity. 5 divided by infinity.
0.
0. So the conclusion, you're going to say horizontal asymptote at y equals 0. And all the AP Calculus kids were like, hooray, I've got it. And they threw this question out because students weren't thinking about both sides. What would happen if you take the limit as x approaches negative infinity?
Oh, no.
X approaches negative infinity, e to the x
It goes this way.
gets close to 0. Subtract 1. You're going to get negative 5. So therefore, you have a horizontal asymptote at y equals negative 5 as well. See you guys later. If it's not polynomial over polynomial, you have to check both. Have to check both. See you later. Yeah.
On Friday, there's a policy, I'm not gonna do that.
Yes. Can you just send me a reminder? Because with my